So how big is this green circle? Alright, we are going to estimate the area of this green circle by comparing it with the area of squares. So the first square I'm going to compare with is this blue square here. As you can see, alright, the circumference of the circle actually just touches the edges of the square. Okay, and we can also see that the area of this green circle is smaller than the area of the blue square. So if we can find the area of the blue square, we can have a rough estimate what the area of the green circle is. Okay, so I'm going to try to find the area of the blue square. So to do that, I'm going to fold this circle into quarters. Okay, right, I'm going to fold it into quarters, and then I'm going to draw the two diameters that cut the circle into quarters. Okay, and then what you can do is you can paste the circle onto the blue square. Alright, and then you get something like this. Okay, now as you can see from the figure here, the two diameters of the circle actually cut the blue square into 4 quarters, and this represents 1/4 of the blue square. This small square here is actually 1/4 of the blue square, and the length of this small square is actually the radius of the circle. Alright, it's from the center of the circle to the circumference. Okay, so to find the area of the blue square, what I'm going to do is I'm going to get a blue square, fold it into quarters. Okay, and then when you unfold it, alright, we have 1/4 of the blue square shaded here. Okay, and the length of this shaded square is actually R by R. So we are going to find what is the area of this small square. So the area of the small square here is equals to length multiplied by length, and since the length is R, it will be R multiplied by R. Okay, so this is the area of one small square. Now we're going to make use of this to find the area of the blue square. So if the area of the small square is radius multiplied by radius, R multiplied by R, then we can say that the area of this blue square here is actually 4 times the small square, 4 times of the small square. So I can write this as 4 multiplied by radius multiplied by radius. Okay, and from this figure here, we can also see that the area of the green circle is actually smaller than the area of the blue square. So our conclusion is the area of the circle here is smaller than 4 multiplied by radius multiplied by radius, which is the area of the blue square. Okay, so our conclusion is this. Okay, next we are going to compare the circle, the green circle, with a pink square. Right, as you can see, the 4 vertices of the green square just touch the circumference of the green circle. Okay. So you can also see that the area of the green circle is bigger than the area of the pink square. So now we are going to find the area of this pink square. So I get another identical pink square. Then what I do is I fold it into quarters along its diagonals. Okay. And let me draw the diagonals of the square. Okay, so if I place the pink square on top of the green circle, you can actually see that the diagonals of the pink square, are actually the diameters of the green circle. Okay, so this is the center of the square. It is also the center of the circle. So if the diagonals is the diameter of the green circle, that means this length here from here to here is the radius of the circle. Okay, because it's from the center of the circle to its circumference. Alright, and just now, as I mentioned, the vertex of the square just touches the circumference of the circle. So this length here is the radius. We also know that the diagonals of a square, alright, bisects each other at 90 degrees. So all the angles here are 90 degrees. Okay, so how do we find the area of this pink square? Now, we can't use the conventional method of finding its area by taking the length of the square multiplied by the length of the square, because the length of the square is unknown. So what I'm going to do is I'm going to cut this square along its diagonal so that I will have 4 right angled triangles. Okay, and then I'm going to place this triangle here with the other triangle to form a small square. Okay, so I am sure that this is a square because this is 90 degrees and this is 90 degrees. Okay, and then the side here will also be R, and this side here is also R. So with the remaining 2 triangles, I can form another small square. side of this small square is R. So the area of this small square here will be length multiplied by length, so it's R multiplied by R. So the area of the pink square which is actually made up of these two small squares here. So it will be 2 multiplied by radius multiplied by radius. 2 multiplied by R multiplied by R. Okay, as mentioned earlier, we already said that the area of the green circle is bigger than the area of the pink square. So we can conclude that the area of the circle is bigger than 2 multiplied by R multiplied by R, which is actually the area of the pink square. Okay, so let us do a summary of what we have learned from our first activity. Alright, when we are comparing the green circle against the blue square, alright, we found that the area of the green circle is smaller than the area of the blue square, and the area of the blue square is 4 multiplied by radius by radius. So the area of a circle is smaller than 4 multiplied by R multiplied by R. Then in our second activity, we are comparing the area of the green circle against the area of the pink square. Right? And then we found that the area of the circle is bigger than the area of the pink square, which is 2 multiplied by radius by radius. So we can conclude that the area of this circle is bigger than 2 multiplied by R multiplied by R. Okay, next we are going to try to derive a formula for finding the area of this circle. Okay, now what you have learned so far is that in primary 3 and 4, you have learned that the area of a rectangle is equals to length multiplied by breadth. You also have learned that the area of a square is length multiplied by length, because for a square its length and breadth are the same. In primary 5, you have learned that area of a triangle equals to half multiplied by base multiplied by height. Okay, so these are the 3 formulae that you have learned to find the area of a rectangle, a square, and a triangle. So what we are going to do is we are going to try to make this circle alright, into either a rectangle, a square or triangle, and then we're going to apply its formula to find the area of this circle. Okay, so what we're going to do is we're going to make use of the formula for finding the area of rectangle. Okay, I'm going to show you how to transform this circle into a rectangle, and then how we are going to use this formula to find the area of the square. Okay, so I have a circle here. So what I did is I have outlined half of its circumference here in black, right? Half of its circumference here in black, and half of its circumference here in red. Okay, now I'm going to cut this circle into sectors. So what I'm going to do is I'm going to fold it into half first, then into quarters. Okay, then into eighths. Okay, right. So I'm going to draw all the lines here, the diagonals here, the diameter here, and cut this circle into 8 sectors. Okay, cut them into quarters, cut them into eighths. Okay, so I have divided this circle into 8 equal sectors, and I'm going to cut it out. So once I have cut it out, I will have something like this. Okay, so what I'm going to do is I'm trying to arrange all the sectors here into a rectangle. So what I'm going to do is I'm going to alternate. Okay, one sector here, the other sector there. Okay, let me try to glue it so that it will not shift. Okay, I have a sector here. Okay, then another sector here. Okay, so you alternate. Okay, you'll notice that I actually place the sectors with the black outline on top, and then the sectors with the red outline at the bottom. Okay, so the circle has transformed to somehow it looks like a rectangle. Okay, so perhaps what we can do here is further cut this into another 2 parts. Okay, so that we can place one part here, and we can place the other part here. Okay, so that it looks more like a rectangle. Okay, now of course if I have cut my sectors into smaller pieces, alright, the shape would look more like a rectangle. Okay, so this is just a rough representation of a rectangle. Okay, what you notice here is that in this rectangle there is a length and the breadth. Okay, so the length is from here to here. Okay, so this is the length of the rectangle, and this is the breadth of the rectangle. Okay, the breadth of the rectangle is actually the radius of the circle. Alright, remember this is actually comes from the center of the circle, and this is a circumference. Okay, so the distance from the center of the circle to the circumference is actually the radius. Okay, so I can say breadth is equals to r. Okay, what about the length? Remember at the beginning I have outlined half of the circumference in red and half of the circumference in black. So you can see that actually all the red circumference here make up the length of the rectangle. So since the red circumference, the red outline here represents half of the circumference, so I can say length is half of the circumference. Okay, and we know that the formula for finding the circumference of the circle is 2 multiplied by pi multiplied by radius. Okay, so what we can do is we can divide both the two here, and what you are left with is pi multiplied by radius. Okay, so we have a length here, we have the breadth here, and then we can make use of our, remember our formula for finding area of rectangle, to find the area of this rectangle now. Okay, so area of rectangle is length multiplied by breadth. So our length here is pi multiplied by radius, and our breadth here is just the radius. So the area of rectangle is pi multiplied by radius multiplied by radius. Okay, now remember this rectangle actually came from this circle. Okay, so we can also conclude that the area of a circle is equals to pi multiplied by radius multiplied by radius. Okay, so this is how we derived the formula for finding the area of a circle.